For tonight's homework, I'm going to have you copy each of these problems down on a separate piece of paper and turn them in. First problem here, I'm finding what D is. So each time I go up by 3, that means I'm adding 3. That makes it an arithmetic sequence. D is 3. If I wanted to find the 0 term, I would backtrack and take away 3 from 4. So find that 0 term. 4 minus 3 gives me 1. So that 1 is the 0 term. 1 is my y-intercept. F0 is 1. Also today we're going to be finding the explicit using the first term, which is 4. And I'm going to show you both and how they both give you the same equation. The recursive, of course, is just taking that f of x equals f of x minus 1 and adding 3. That is recursive. For explicit, I'm going to take that 0 term explicit is always f of 0 plus d times x. Or also use f of x equals f of 1 plus x minus 1 with d distributed right there. Both will give you the same. Here we go. For the first one, I'm going to plug in the 0 term, which is 1, and my d term, which is 3. I'm going to write it in slope-intercept form, so that answer is f of x equals 3x plus 1. If I take that other equation and instead of using the 0 term, if I use the first term instead and plug in 4 right there for f1 plus x minus 1 with 3 on the outside there, I'm going to distribute that 3 and combine my like terms, and I should get that same slope of x and y-intercept of 1. So this gives me f of x equals 4 plus 3x minus 3, and I fix that. Combine my 4 and my 3, and that final answer gives me f of x equals 3x plus 1. And if you were to graph that, 0 would be x, 1 would be y. You need to be able to graph those points on a graph. So 0 for x, 1 for y, 1 for x, 4 for y, 2 for x all the way up to 7, 3 for x up to 10, and then 4 for x all the way up to 13. Draw my line through them because we're graphing again the explicit continuous functions. And again, if you look at that line, it has a y-intercept of 0, 1, where it touches the y-axis is 0, 1, or the 0 term, and it has a run of 1 and a rise of 3. So the slope is 3, the same as my common difference. Common difference number is always the slope or the rate of change. All right, next. These problems deal with the concept of when do you use recursive or when do you use explicit. This first problem here, it gives you the 8th term and it's asking you to jump ahead to the 20th term, so you would not want to use recursive here. You'd want to use explicit. You want to take that equation 10x minus 2 and plug in 20 for x into that equation, because again, I want to jump from the 8th term to the 20th. So when you're jumping ahead, use explicit. So in there where x used to be, I plug in 20. 10 times 20 is 200, minus that 2 gives me 198. For the next problem here, I am giving you the 8th term and having you go ahead to the very next term. So whenever you're trying to find the very next term in a sequence, use recursive. Know the previous term, know the math that you're doing, and do that to get the next term. So I know the 8th term is 78. I know I'm adding 10 each time. So if I take that 78 and add 10, gives me 88. which again is much easier than instead plugging in 9 into x right there and multiplying 9 times 10 and getting 90 minus 2, which is the same answer, but more work. All right, next, discrete, continuous, linear, exponential. Any kind of problem that has you wait until a certain time for it to happen again, wait till the next day, is discrete. Anything happening continuously over time is continuous. Any graph or any function that is arithmetic is linear. Any problem that is geometric, exponential. So know all these. So that first problem there, pouring concrete once a day, having to wait until the next day to pour it, that makes it discrete. Concrete is not pouring out continuously 24 hours a day, so I would make that discrete. And then that would be linear because, again, I have nothing to do with multiplying. That is an arithmetic sequence, adding 300 each day, plus 300, plus 300, discrete. This next problem here, bacteria doubling. Anything doubling, tripling, which means you're multiplying, makes it geometric, which is exponential. Because this bacteria is continuously changing over time, 24 hours a day it's changing, that's continuous. So this is because it's changing constantly, and exponential because it deals with timesing. Problem number 7 has the bricklayer 5%. Anytime you see a percent, that is timesing. That makes it geometric. That makes it exponential. And then this problem here, laying bricks each day. I would say it's continuous because they're continuously laying them down over the workday. They don't have to wait till the next day to lay down bricks. And that would be exponential because it deals with multiplying. Next problem's based on just the function given to you or the graph, same thing. Anything in recursive form, always discrete. That is a recursive form where you're adding, that makes it an arithmetic sequence, so that means it's linear. Arithmetic, linear, geometric, exponential. This is recursive always discrete, and it is arithmetic, so that would be linear. Anything explicit is continuous, so know that. For this graph, I have just dots. Just dots make it discrete. If I drew a line through them, that would be continuous. These lines, this makes up a curved line. That is the exponential look to it. So this would be a discrete exponential because, again, it's just plain dots and it follows that exponential curve. The last one here, that is a explicit form. Explicit, always continuous. That is a explicit form for a multiplying sequence, which is geometric. Geometric, always exponential. So this would be continuous, exponential. So again, know the difference between discrete and continuous, and linear and exponential. Discrete, always something you gotta wait for, or recursive. Continuous, something continuously changing over time, or explicit. Arithmetic, always linear. Geometric, always exponential. All right, for these, to combine two equations to get a third equation to graph, I have to first write the equation for both lines and then combine them together to get that new equation. So that g of x line has a y-intercept of 5. Every time I go over 2, I go up 1 for my slope. That f of x line has a slope of negative x over 1, down 1, and has a y-intercept of 0. All I have to do is combine those two together to get my new slope and my new y-intercept and graph them. Negative 1x plus a half combines to give me negative 1/2 x. I will fix that. 5 plus 0 is 5. So again, I'm plugging in both equations. I'm going to combine my x terms and combine my plain numbers. So 1/2 minus 1 really gives me negative 1/2 right there. So I will fix that. So that means when I graph that new line, I start at 5 on the y-axis, but every time I go over 2, I go down 1, over 2, down 1. That is the new line. That is the h of x line, which is the line from both those lines combined together. Draw my line through them, label them, and then my next one, a of x. That one has a slope of 1x plus 5. B of x looks like it has a y-intercept of negative 1 and a slope of over 2 down 1, so a slope of negative 1/2. Again, to get the new line s of x, I'm going to combine both those together. So I'm going to combine my x's and combine my y-intercepts. So 1x minus 1/2 is going to give me 1/2 x. 5 minus 1 is going to give me positive 4. So this new line is 1/2 x plus 4. Graph it. So go to 4 on the y-axis, over 2, up 1, over 2, up 1. Draw my line through them. And that gives me the new line s of x. All right, on these next problems, if I give you this, that means I'm giving you the x number. Find 0 on the x-axis, hit that line up or down, and see what that is on y. So at 0 for x, hit that line, I get negative 5 on the y-axis. The next problem, instead of me giving you the x number, I'm giving you the y number. So you go up to 1 on the y-axis, go to hit that line, and then look down on the x to see what that is. The next problem, I'm giving you 3 on the x-axis, so hit that line, look over. That's not down very much, so I'd say about negative 1/4. And then the last one, negative 2 on the y-axis, hit that line, go up or down, that would give me 2. Next one's again, d of negative 5. I'm giving you that on the x-axis, hit the line up or down. First one you hit, look to the right, and that would be 1. The next problem down, I'm giving you that 4 on the y-axis, so find 4 on the y-axis. Hit that line left or right, look down, see what that is on the x-axis, so 3. D of 4, find 4 on the x-axis. Go up or down until you hit the line. First line you hit, look over, see what y is, so that'd be 2. And then the last one, that is x. That means 0 on the y-axis, and then hit that line, and of course that would be 0. All right, inequalities. Graph inequalities. Read what that inequality says. That says x is less than 6. So find 6 on the x on your number line. Shade to the left. That would be an open circle because that is just plain old less than. And then for interval notation, that would be negative infinity to the left, 6 rounded. Make sure you know how to write interval notation. X is more than 5. So find 5. That's going to shade to the right because more than always to the right, less than to the left. Open circle because that's plain inequality. I'm going to write this one in set notation. You need to be able to write in both set and interval notation. So set notation has you just write x is an element of the real numbers and just put that inequality in there. Next one, x is more than or equal to negative 9. So that would be a solid circle, shaded arrow to the right. And interval notation would be square bracket negative 9, rounded bracket infinity. These compound ones, This is shaded between -7 and 0, where -7 gets the solid circle, 0 gets the open circle, shaded in between, and then interval notation from -7 square to 0 rounded. Next one, from 3 solid circle to 25, shaded everywhere in between. Interval notation has that from 3 to 25 square. And then the last one, -15 to 8. -15 gets the rounded, 8 gets the solid, shade in between. And then for interval notation, that would be rounded -15 to square on the 8 because the inequality in the circle. All right, and then set notation would be x as an element of the real numbers, and then just put that whole compound inequality right in there for set notation. So no set and interval notation. All right, these are literal equations. I'm going to show you one. So for this one, I'm solving for h. So 25 times pi times h, the opposite, dividing by those. So I divide those out. That gets me the h all by itself. So again, know how to solve literal equations. H is q divided by 25 times pi. Be able to rearrange it. I'm going to show you 17 and 18 here. So 17, to solve this, I'm going to add 9 to both sides. And that gives me 2/5 x equals 15. To solve this, I'm going to multiply both sides by the reciprocal, which is 5/2. The reciprocal of 2/5 is 5/2. I'm going to multiply the other side by the reciprocal. Anytime you multiply a fraction by a reciprocal, it cancels away. And on the left side there, multiplying straight across, 15 times 5, I believe, gives me 75. And then 2 times 1 just gives me 2. So that gives me 75 halves. I'm going to take that same equation, but instead of -9, it's going to be -9y, and I want you to see how that changes it. So for this problem, instead of adding 9, I'm going to add 9y. And because that's 9y and 6, I cannot combine unlike terms. Unlike the one to the left there where I can add 9 and 6 to get 15, for these I cannot combine these, so I just write them next to each other. So 9y plus 6. I'm going to multiply both sides by the reciprocal. Anytime you multiply a fraction by its reciprocal, it cancels away and just leaves you x. Over here, I need to distribute that 5 halves times 9y and that 5 halves times 6. So 5 halves times 9y gives me 45/2. 6 times 5 halves gives me 30/2. And that 30/2 simplifies into plain old 15. So 45y/2 plus 15. All right, last ones are graphing and checking inequalities and intercepts. So this inequality here, I'm going to start at 4 on the x-axis. Every time I go over 1, I'm going to go up 3, over 1, up 3, stair step the opposite direction. So the y-intercept is 4. The slope is over 1, up 3. My inequality makes that a solid line that is less than, so I will shade below. To do a check, I'm going to pick a point in that shaded zone. So it looks like the point 0, 0 is right in the middle of that shaded zone. So if I plug in that coordinate 0, 0 for x and y, it should check in that original inequality. So where y is, I plug in 0. Where x is, I plug in 0. 3 times 0 is 0. That gives me 0 less than or equal to 4, which is a true statement. So that proof did work. All right, next graph has a y-intercept of 2. It's going to go over 5, down 3. So from that point, right 5, down 3. Right 5, down 3. Be able to stair step. That is a dotted line because of that inequality being just plain old more than. More than means shade above. To pick a point to check, I'm going to pick a point in the shaded zone. So it looks like I'm picking the point 2 for x, 3 for y, which should give me a true statement. So when I plug in 3 for y and 2 for x, it should give me a mathematical true statement. And that does true because negative 6 over 5, which is just over negative 1 plus 2, there's no way that's going to be more than 3. So that is a true statement. All right, next one. Negative 2 is my y-intercept. Over 1 up 7 is my d, or my slope, or my rate of change. Dotted line, because of inequality. Less than means shade below. And this last one, y greater than negative 6, find negative 6 on the y-axis. That's going to be a horizontal line where every point on that line has negative 6 for y. More than, it's going to be shaded above, and that line is solid because of the inequality. All right, last two, intercepts. So remember, for the x-intercept, you know that y is 0. For the y-intercept, you know that x is 0. So for the x-intercept, take that equation where there is a y, I'm going to plug in 0 for y. So that gives me 6x plus 2 times 0 equal to 18. Solve that for x. Divide by 6, and that gives me x equals 9. I'm sorry, 3. Next one, plug in 0 for x instead. So 6 times 0 plus 2y. That gives me 2y equals 18. That means y equals 9. And then they want you to plot those points. So 3, 0 on the x-axis, 0, 9 way up on the y-axis. Draw your line through them. That is any equation like that is explicit. Draw a line through them. Continuous. And that is linear. All right, last problem. For the x-intercept, plug in x is 0. For the y-intercept, plug in y is 0. So right here, where y is 0 just disappears, and all I'm doing is solving for x. So negative 2x equals negative 14, x equals 7. For the y-intercept, where I plug in x is 0, x will disappear. So I'm just solving for y right there. So some people will do that. That gives me y equals negative 2. So the x-intercept has 7, 0, and the y-intercept has 0, negative 2. Draw your line through them. And again, a good review of all the kind of problems you need to know for the final. Write these down on a separate piece of paper. Turn them in tomorrow. Good luck.